All right, guys, what's up? This is our second lesson for Math 8. It's kind of pretty similar to 1.1. So these two lessons kind of go together, which means that the good news is this is a pretty short lesson. All right, so this one is comparing real numbers. All right, so we'll just skip that first page. We don't need it. We're going to look at this key concept, okay? So last lesson, we talked about rational numbers. We said a rational number is a number that can be expressed as the ratio a over b, okay? Where a and b are integers and b is not 0, okay? That's just another definition that means the same thing that we learned last time. I know that's not the exact same definition we had, but they mean the same thing, okay? An irrational number, okay, so this one's new, is a number that cannot be expressed as a ratio a over b where a and b are integers and b is not equal to 0. Okay, so to sum up, 1/4 is rational because it can be expressed as a ratio a over b. So 1 takes the place of a and 4 takes the place of b. Okay, and both of those numbers, 1 and 4, those are both integers. Okay, so we know that this is a rational number. An irrational number would be something like they have here, the square root of 2, where it's going to go on forever. That's kind of how you can remember irrational is irrational goes on forever, and I'll write that down. So irrational goes on forever and it doesn't have a pattern. Okay, so you'll notice if you type in square root of 2 on your calculator and hit enter, or if you just look at what they did in the book, you can see there's not really a pattern that goes on there. Okay, square root of 2, there's also no way to write it with a over b where they are both integers. Okay, so now we've got this figure again here. We had one just like it last class. The difference is we didn't have this box right here on the right side. Okay, that's just irrational numbers. So more examples of irrational numbers here. You've got pi, you've got 1 point, I'm not sure what that one is, and then you have the square root of 3. Those are all 3 irrational numbers. Okay. The important thing to know here is that irrational numbers are also real numbers, okay? So real numbers are the collection of rational numbers along with irrational numbers. Okay? So moving on, we'll look at some examples. So example number 1 here, the decimal ends in a repeating pattern. Okay, so you have this decimal here, 0.252525, and that 25 repeats on and on. We know that's a rational number because it is equivalent to 25 over 99. 25 and 99 are both integers. Okay, this symbol I'm making here just means integers. All right, so if you're curious what that symbol is, this is just a side note. It's a Z with a line through it. If you see that, that means integers. Okay, the next bit on example 2, you have the square root of 36. If you were to type that into your calculator, or if you just know it off the top of your head, the square root of 36 is 6. Okay, 6 is a natural number, which was in our diagram up here. Natural numbers, it's that green circle there. So those are counting numbers. And anything there is going to be within that zone of rational numbers. All right. Lastly, example number 3, you have negative square root of 7. Okay, the square root of 7, if you type that in to your calculator, you're going to get something that does not terminate or repeat, as this says here. So that's how you know that it's an irrational number. Okay, so I want you to go ahead and pause the video. On your own, I want you to do letters A, B, and C. So I want you to just tell me if they are rational or irrational. Okay, so go ahead and pause the video now and do that. All right, once you're done with that, we'll move on to the very next page. So compare and order real numbers. Basically what this is doing is you're looking at different numbers written in different notations, and you're just comparing them. The way you compare them is by making them all in the same form. The easiest way to do this is going to be decimal form. Okay, so if you look at example 4 here, they do that with both of these numbers. They put square root of 7 into decimal form, and then they put 2 2/3 into decimal form. All right, excuse me. So square root of 7 is approximately 2.6457 on, and then 2 2/3 is approximately 2.66 repeated. Okay. At that point, you just compare which one is greater. So you've got 2.66 repeated, and you have square root of 7, which is 2.6457 ... Okay, I know that 2.66 is greater than 2.64, so that's as far as I need to look to know that this number is greater than this number. Okay, remember, greater than is this symbol. Okay, so what I like to look at it as, whichever side has the 2 points is greater than the side that has the 1 point. Okay, it's just a little refresher for you. All right, so if you want to look at number 5 or number 6 on your own, just to see another example of that, feel free to do so. I'm going to go ahead and have you guys move on to these got it problems down here. I want you to do D, E, and F. Okay, so just do D, E, and F on your own. Go ahead and pause the video and do that right now. Okay, so once you've done that, that is the end of this lesson. Like I said, this one's nice and short. So I will see you back in class.